So good evening, welcome to SAKALAVIDYA YouTube channel. Are you able to hear my voice? Are you able to hear my voice? Yes or no? Murthy, Vamshi, Sham, Sai, Vishwik Vardhan Reddy. Are you able to hear my voice or not? Audible? Thank you, thank you. Okay. So in the last class actually binomial theorem part 6 we have completed. In that one up to 53 problems we have completed. So today 54th problem we shall complete it. Thank you, thank you, thank you. Thank you, thank you. Any new viewers are there, please subscribe and share, like and share. Okay, right, let me start now. Binomial theorem. Binomial theorem part 7. This is part 7. Part 7. Definitely probability I will start. Don't please ask the questions. Function problems video. So not yet. Actually theory is going on. Okay. 54th question. 54th problem. Good evening, Surya Prakash. 54th. If the fifth term of q upon 2x minus px raised to 8 is 1120 1120 and p plus q equals to 5. P plus q is equal to 5. P greater than q. Then P equals to okay, first option 3, second option 6, third option is 4, fourth option is 7. So this is the question. Okay, Ayush Poti, you ask later any doubt you have. Okay, let me solve the problem first now. Solution. First, let us find out the fifth term of this expansion. Fifth term. That means T5 we need to find out. T5. T5 equals to, we can write T4 plus 1. T4 plus 1 equals to 8C4 because NCR. Q upon 2x whole to the power of 8 minus 4 is 4 and minus px whole to the power of 4. So this is given that this is equals to 1120. Okay, this one given 1120. So now we need to find out p value providing p greater than q, keeping this condition. Right now this we can write now 8C4. So 8C4 equals to 8 multiplied by 7 multiplied by 6 multiplied by 5 upon 4 multiplied by 3, 3 multiplied by 2, 2 multiplied by 1, and this will be, you can write 1 by 2 power 4 is 16 into this will be q power 4, okay, q power 4 upon x power 4 multiplied by this will be p power 4 and multiplied by x power 4 equal to 1120. So we need to do the simplification. X power 4 gets cancelled. Actually here we have C 3 2 ja 6, 6 cancel. Now 4 2 ja 8. Okay. This we have actually 70 upon 16. 70 upon 16 pq whole power 4, because p power 4 q power 4 can be written pq power 4 equals to 1120. Okay. So now the pq whole to the power of 4 equal to, we can write 1120 multiplied by 16 by 70. 0 0 cancel. This is 7 16 ja. This will be, we can write 2 power 4, this 16 into 16 256, that will be, you can write 4 to the power of 4. So pq equals to 4, but what is given? P plus q equals to how much given? 5 given. That means factors of this one we can write 4 1 ja. So that means this can be written as 4 plus 1. Since p greater than q, so this will be the p value. Therefore p equals to 4. That means it's very clear that third option is the right option. Third option is the right option. Okay, you can check it now, solution, all of you. Fifty-five. 55. Right now, option 3, absolutely correct. Right. If 0 less than x, x less than 1, x less than 1, less than 1, then the first negative term, in the expansion of 1 plus x whole to the power of 7 upon 2 is first option 6th term, second option 5th term, third one 4th term, fourth is third term. That means in that one, first negative term, which term of this expansion is the first negative term, that we need to find out. For that one we have the one shortcut, so note down that shortcut. What formula? Shortcut formula. So you remember the shortcut. The first negative term in 1 plus x whole to the power of p by q, because rational index where q does not equal to 0 is integral part of p by q, it's integer function, plus 3. So you remember this shortcut. So now here we need to find out. First integral part of 7 by 2. That means integral part of 3.5. In 3.5 decimal point we need to neglect it. 3 plus 0.5. It will be 3. So that means now the first negative term. The first negative term is given by, this is 3 plus 3, that is equal to 6th term, or we can say T6. So first option is the right option. Option 1 is the right option. Next, let us move to the next problem now. Okay. Fifty-sixth problem. Sum of the binomial coefficients sum of the binomial coefficients in the expansion of 2x upon 3 plus 3 upon 2nx square raised to n is equal to 64. Okay, 64. The term independent of x. The term independent of x is first option 27 upon 5, second option 5 upon 27, third option 7 upon 27, fourth option 27 upon 7. So okay, first read the question. Right. So Tanish, Nelly, could you forward that method for me? Could you forward it, first one, please? Okay. Read the question, all of you, once again. Sum of the binomial coefficients in the expansion of 2x upon 3 plus 3 upon 2n x square raised to n is equal to 64. The term independent of x we need to find out. So that means, first of all, this problem need to be done. First we need to find out n value. So after getting n value, we need to find out the term independent of x. Okay, let us find out in that way. So we plot the method now. So first, the sum of the binomial coefficients here given 16. That means put x is equal to 1 here. So then you will be getting the n value. After getting n value, then independent of the term independent of x we need to find out. Okay, now r is equal to n by 3. Okay, that's all. Right. 56 solution. 56 solution. See, sum of the binomial coefficients. Sum of the binomial coefficients. Coefficients of 2x upon 3 plus 3 upon 2nx square raised to n equal to 64. That implies put n is equal x is equal to 1. Then we get now 2 upon 3 plus 3 upon 2n whole to the power of n equal to 64. Equal to 64. Okay. Next we what we need to substitute, this will be 2 by 3 plus 3 by 2n all to the power of n is equal to 64. Right, this relation we will get it now. Sum of the binomial coefficients in the expansion is equal to 64. Okay, that is 2 by 3 plus 3 by 2n all to the power of n is equal to 64. The term independent of x we need to find out. Right. Next, let us go for, say, equation 1. This is, let tr plus 1 be the independent term, or r value let us find out now here. R value. So R value equal to NP by P plus Q. Here N means N only, P means 1. By here actually you will be getting 1 plus 2, 3. R is equal to N by 3. R is equal to N by 3. We got it now. Right. R is equal to N by 3. N should be the multiple of actually what now here? Definitely N should be the multiple of 3. Multiple of 3 means, for example, substitute here 3. What do you get now here? If you substitute N is equal to 3, what happens? 1 by 2. So 1 by 2, no, you won't be getting. For example, N is equal to 6 if you substitute. Here N is equal to 6 means 1 by 4. 1 by 4. Okay, now this must be, see, we got N by 3 is equal to R value. N by 3. N is a multiple of 3 means, for example, sometimes 0 may be there. but if you put 0 cannot be right. So here n may be 3, 6, 9 and 12 and so on like that. Okay, so if you put 6, what do you get? 1 by 4 you will be getting. So 9 means you will be getting 1 by 6. 1 by 6. 2 by 3 plus 1 by 6, let us see. 2 by 3 plus 1 by 6. 2 by 3 plus, take 6, n is equal to 6, 1 by 4. Here LCM is 12, 8 plus 3. No, not getting. Okay, I will check this problem later. For example, if you take n is equal to 3, what happens now? 1 by 2. 1 by 2 means 4 plus, no, 64. 64 means 2 power 5 you will be getting. Right, something might be wrong in the question. Okay, I will check later. I will come to, okay, I will discuss later this question. Okay. Right. 56th question. The sum of the coefficients in the expansion yes, something is wrong with the problem, is there, of x plus y all to the power of n is 4096, then the greatest coefficient is first option 11C5, second option 12C5, third option 12C6, fourth option 14C7. So this is the question. Right. Ashfaradi, how did you get that one? Put n is equal to 3. Okay, I will check later. I will come back. Okay. So the sum of the coefficients in the expansion of x plus y all to the power of n is, the sum of the coefficients in the expansion x plus y all to the power of n is 4096. Then we need to find out greatest coefficient we need to find out. So that means first let us find out sum of the coefficients. Sum of the coefficients means put x is equal to y is equal to 1. So we get this 1 plus 1 all to the power of n equals to 4096. This is 2 to the power of n is equal to 4096. Now the prime factorization of 4096, let us write it. 4096 means, actually you can write like this: 2 20 ja, 2 4 ja 8, 2 8 ja. Next 2 10 24, 2 5 12, 2 256. This is 2 128, 2 into 64. Okay, this we can write now 1, 2, 3, 4, 5, 6. 2 power 6, this is 2 power 6. 2 power 12 you can write. So that means n equals to 12. N equals to 12. The greatest coefficient. Greatest coefficient means greatest coefficient is equal to greatest coefficient is equal to NC n by 2. If n is even, obviously this is even itself only. So we can write now this equal to 12C n by 2, 12C6. That means third option is the right option. Third option is the right option. Okay, now let us check the previous question now. If you put n is equal to 3, what happens? N is equal to 3 means actually here n is equal to 3 means R must be 1. R must be 1 only. That means second term. Let us try. 2 by 3 plus 3 by 2. 6 LCM here. 3 2 ja 4 plus 2 3 ja 9. No, we won't be getting. Okay. Right. So now 57. Question number 57. Question number 57. Question number 57. Right. In the expansion of x plus a all to the power of n, x plus a all to the power of n, x plus a all to the power of n, sum of the odd terms, sum of the odd terms is P, is capital P. Sum of the odd terms is capital P. Okay, I will check later. Ashwaradi, leave it now. Sum of the odd terms is P and the sum of the even terms is Q. Then 4 times PQ equals to 4 times PQ is equal to first option x square minus a square all to the power of n, second option x plus a all to the power of 2n plus x minus a all to the power of 2n, third option x plus a all to the power of 2n minus x minus a all to the power of 2n. Now fourth option x minus a all to the power of 2n minus x plus a all to the power of 2n. This is the question. Right. So now in the expansion of x plus a all to the power of n, sum of the odd terms is capital P and sum of the even terms is capital Q. Then we need to find out 4 times capital P multiplied by capital Q. we need to find out. 4pq we need to find. Right. 58 solution. 58 solution. So consider x plus a all to the power of n equals to this x plus a all to the power of n actually consisting of n plus 1 terms. So we can write like this: first term t1, second term t2, third term t3, fourth term t4 plus t5, and so on. We have this will be, there will be n plus 1 terms. This t1, t3, t5 are called actually odd terms. t2, t4, t6, t8 are called even terms. So this can be written as like this. So now t1 plus t3 plus t5 plus dash dash dash, we can write as a sum of the odd terms plus sum of the even terms. You can write this is t2 plus t4 plus t6 dash dash so on. So already this is given that sum of the odd terms is capital P, sum of the even terms is capital Q. So this can be written now, this can be written as capital P plus capital Q. Say equation 1 this is. Now from this one easily we can write x minus a whole to the power of n expansion. So let us write x minus a whole to the power of n. X minus a whole to the power of n is equal to t1. They have the same terms just like x plus a whole to the power of only, just they differ by the only symbol change. Okay, Ashwaradi. Right. t1 minus t2 plus t3 minus t4 plus t5, and next minus so on dash dash minus 1 to the power of n tn plus 1. So this can be arranged like this: t1 plus t3 plus t5. This we can write as the difference of odd terms and even terms: t2 plus t4 plus t6 plus so on dash dash. So we know that from the given data this can be replaced by P, this can be replaced by Q, so that we can write this is equal to P minus Q. Just in the place of plus write down minus sign, you get x minus a whole to the power of n. But what we need to find out, 4pq we need to find out. See, from basic algebra we need to apply. What is the basic algebra? See, 4ab, that means 4pq. This 4pq is equal to, we can write p plus q whole square minus p minus q whole square. This is the basic algebra. If you simplify p plus q whole square minus of p minus q whole square, you get 4pq itself only. Now here you check it now, p plus q is x plus a whole to the power of n, replace it. This equals to, we can write x plus a whole to the power of n and raise it to 2, and minus this is x minus a whole to the power of n and raise it to 2. So this can be simplified as x plus a whole to the power of 2n minus x minus a whole to the power of 2n. Just check your options now. Which is the correct option now? Which is the correct option? I think 3. Am I correct now? This is the method, 58 method. You follow it now? I think you might have followed. Right. Third option. 59th question. 59. Question number 59. The term independent of x in 1 plus x plus 2x square times 3x square upon 2 minus 1 by 3x upon 9 is, first option is 13 upon 54, second option 15 upon 54, third option 17 upon 54, fourth option is 19 upon 54. Right, this is the question. Anybody? What is the answer? The term independent of x in 1 plus x plus 2x square times 3x square upon 2 minus 1 by 3x upon 9 is. So now how could you solve this problem? Actually, in the first factor we have three terms. 1 multiplied by independent term, x multiplied by, you need to find out x to the power of minus 1 coefficient, and 2x square, 2 times of x to the power of minus 2 coefficient of 9. Actually, three sums you need to do it now here in this case. Right. Here first, let's make a plan now. Independent term is equal to independent of x equals to, we can write like this: 1 multiplied by independent term of this 3x square upon 2 minus 1 by 3x whole to the power of 9. Okay, plus what is the x coefficient here? 1 multiplied by x to the power of minus 1 coefficient in same expansion whole to the power of 9, and plus here x square coefficient is 2 multiplied by x to the power of minus 2 coefficient in same expansion whole to the power of 9. So that means actually here independent term of the expansion we need to find out, x to the power of minus 1 coefficient we need to find out, and x to the power of minus 2 coefficient also we need to find out. For that one, let us say here tr plus 1 be general term. Let us write general term. That will be 9cr. We can write 3x square upon 2 whole to the power of 9 minus r, and minus 1 by 3x whole to the power of r we can write. This equal to, we can write 9cr 3 by 2 whole to the power of 9 minus r minus 1 by 3 whole to the power of r, x to the power of, this will be 18 minus 2r, and this is minus r, that will be 18 minus 3r. Okay, See, to get constant term here, first let us go for this first step now. First one, this one, right? For independent term, 18 minus 3r equals to 0. R value will be 6. So that means here coefficient that will be 9c6 3 by 2 whole to the power of 9 minus 6 is 3 and minus 1 to the power of minus 1 by 3 whole to the power of 6. This into 1 by 3 to the power of 6. So we need to simplify this one. And next, for x to the power of minus 1 coefficient, see 18 minus 3r equals to minus 1. So now 3r equals to 19. R equals to 19 by 3. It is not integer. So x to the power of minus 1 coefficient does not exist. This does not exist. So this will be 0. This will be 0. Leave it now. So next, what we need to find out now? X to the power of minus 2 coefficient. For x to the power of minus 2 coefficient, this 18 minus 3r is equal to minus 2. So that means actually here 18 plus 2, 20 equals to 3r. R value equal to 20 by 3. It's not integer. So now it's clear that actually, so this also does not exist. This will be 0. Only independent term we need to find out. Independent term means this we need to simplify. So now independent term equals to 9c6. 9c6 means 9 into 8 into 7, because 9c6 equals to 9c3, because 9 minus 6 is 3. So 3 into 2 into 1 into 3 cube. 3 cube is 27 upon 2 cube is 8 to 1 by 3 power 6. 1 by 3 power 6 means 9 into 3 square is 9. 3 square is 9. 3 power 4 is 81. Okay. This will be 8. 8 gets cancelled. We have next 9 3 ja. 3 3 gets cancelled. So now 9 9 ja. Okay, what is the answer you will be getting? 7 by 18 you will be getting. 7 by 18 you will be getting. Okay. 9c6. Okay. 9c3, 9 into 8 into 7 by 3 into 2 into 1. Okay, you check your answer. 7 by 18 you will be getting. Okay, 7 by 18. The 60th problem. The coefficient of the coefficient of middle term, the coefficient of middle term in the expansion, of 1 plus x whole to the power of 40 is 1 plus x whole to the power of 40. First option 1 into 3 into 5 into dash dash 39 upon 20 factorial into 2 power 20. Second 1 into 3 into 5 dash dash 39 upon 20 factorial. Third one 40 factorial by 20 factorial. Fourth option 40 factorial into 20 to the power of 20. This is the question. Right. So the coefficient of middle term in the expansion of 1 plus x whole to the power of 40 we need to find out. So that means 60 solution. Consider 1 plus x whole to the power of 20 or 40. Here n is equal to 40, which is even number. Even number means middle term equal to n by 2 plus 1th term. Am I correct now? There is only one middle term, that is n by 2 plus 1th term. That means here n by 2, 20 plus 1, 20 first term. So now the greatest coefficient, the coefficient of the 21st term is the greatest coefficient term. That means actually here T21. This we can write T20 plus 1 equals to, we can write 40C20 into x to the power of 20. We need coefficient only. We need this only, coefficient. Therefore, greatest coefficient is equal to 40C20. This is the answer. 40C20 means we have one shortcut formula. Let me explain shortcut. What is the shortcut means? 40 is the even number. This is 2n, for example. This will be the half of 40, n. See, we have one shortcut. What is the shortcut means? This 2n cn equals to 1 into 3 into 5 into dash dash 2n minus 1 upon, you can write n factorial into 2 power n. This you can remember. 2n cn equals to 1 into 3 into 5 into dash dash 2n minus 1 upon n factorial into 2 to the power of n. So here you remember n, clear, it is clear that n is equal to 20. So this equals to, we can write now 1 into 3 into 5 into dash dash 20 into 2, 40 minus 1, 39 upon n factorial. N factorial means 20 factorial into 2 to the power of n. n means 2 to the power of 40. So this is the answer. So that means first option is the right option. First option is the right option. First option is the right option. This is equal to 40C20 itself only. 40C20. Sixty-one. The coefficient of x to the power of 53 in the expansion of sigma m is equal to 0 to 100 cm x minus 3 all to the power of 100 minus m into 2 to the power of m is. This is the question. Okay. First option 100C53. Second option minus 100C43. Third one minus 100C53. Fourth option is 100C50. See, the coefficient of x to the power of 53 in this expansion we need to find out. See, from binomial theorem we know that sigma r is equal to 0 to n c r x to the power of n minus r. A power r is nothing but x minus a all to the power of n. This is the definition of the binomial theorem. Am I correct or not? So this is nothing but binomial theorem itself only, binomial expansion, which is in the form of x minus a all to the power of n. What is x? Here x means x minus 3, a means 2, x minus a, x minus 3. Here what you need to write now here, sorry, this is x plus a all to the power of n. X minus 3 plus 2 all to the power of n means 100. You can write it because here n ist is 100. So this we can write now. This given expansion, let us say yes, this expansion series is equal to s is equal to, we can write x minus 3 plus 2 all to the power of 100. So this equal to, we can write x minus 1 all to the power of 100. Because 100 is an even number, this we can write 1 minus x all to the power of 100. No problem. Because if you take minus sign, minus 1 to the power of 100 is plus only. So here in this one, what we need to find out? X to the power of 53 coefficient we need to find out. X to the power of 53 is actually in this one. X to the power of 53 coefficient we need to write. That is equal to minus 1 to the power of 53 into 100 C53. So minus 1 to the power of odd number is minus. So minus 100 C53. So that means third option is the right option. Third option is the right option, not first option. Because minus 1 to the power of 53 is there. That you need to remember. Right. Sixty-two. the coefficient of x to the power of 5 in the expansion of 1 plus x all to the power of 21 plus 1 plus x all to the power of 22 so on plus dash dash 1 plus x all to the power of 30 is the coefficient of x to the power of 5 in the expansion of 1 plus x all to the power of 21 plus 1 plus x all to the power of 22 plus so on plus 1 plus x all to the power of 30 we need to find out. So that means first option is 51C5, second one 9C5, third one 31C6 minus 21C6, fourth one 30C5 plus 20C5. This is the question. The coefficient of x to the power of 5 in this expansion we need to find out. So first let us do one thing. Take 1 plus x all to the power of 21 common. So now what do we get now here? 1 plus 1 plus x plus next will be 1 plus x whole square and plus dash dash. This we can write 1 plus x whole to the power of 9 we can write it. Am I correct now? If you observe this one, this is geometric progression. First term is 1. Here actually we have, this is 1 plus x is the common ratio. Here we get like this now. This a equals to 1 and next r value is equal to 1 plus x. N is equal to 9. Sn formula. Sn is equal to, we can write a into r to the power of n minus 1 by r minus 1, you can write it. This is the sum to n terms of geometric progression. We need to apply the geometric progression. So now this can be rewritten as 1 plus x all to the power of 21. So multiplied with a stands for 1, leave it. R value is actually how much? R value is 1 plus x. 1 plus x. So 1 plus x all to the power of 9 and next minus 1 upon we have, this is 1 plus x minus 1, this will be x. So this can be written like this: 1 plus x all to the power of 21 into 1 plus x all to the power of 9. 1 plus x all to the power of 30 upon x minus 1 plus x all to the power of 21 upon x. So now very simple here. We need to find out x to the power of 5 means already by x is there. In this expansion we need to find out x to the power of 4 coefficient. So in this one we need to find out x to the power of 4 coefficient. So that means now therefore x to the power of 5 coefficient is equal to, it's very clear, 1 by x multiplied by x to the power of, here what we need to write now, x to the power of 5 we need. X to the power of 5 means x to the power of 6, sorry, x to the power of 6 coefficient of 1 plus x all to the power of 30 we need to find out. Because x to the power of 6 by 6 it becomes x to the power of 5 minus 1 by x into, here also x to the power of 6 coefficient of 1 plus x all to the power of 21 we need to find out. See, x to the power of r coefficient in 1 plus x whole to the power of r is NCR. So that means here we can write 30C6. This is 30C6. 21 we have taken common. It's okay. 9 into r to the power of n minus 1. Right. N is how many terms? Sorry. N is actually here 10 terms including 1. This n is 10. Forgotten? Sorry. N is 10. N is 10 means this will be 10. This will be 31. This will be 31. This is 20. This will be 21 only. Right. This is 31. So we get 31C6 minus this is 21. 21C6. That means third option is the right option. Third option is the right option. Okay. So thank you. Tomorrow we shall continue the class, the functions class. Actually tomorrow we shall discuss problems, because already we have completed some part of the introduction. So generally I planned functions in such a way that first introduction followed by the problems of the same models. After that I will discuss the introduction, then followed by the problems. So in this way actually I planned. Tomorrow we shall meet you by 9:30. Thank you. Bye bye. See you.